Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 712. Please turn to it, page 712, and today is our lesson number 81. Let's take a look at it. This section has 18 questions, as I always remind you when we get to sections such as this one. It has 18 questions. The first 8 are multiple choice, and the next 10 are graded questions, because there are two types of questions in this section, which means there are two separate scale of difficulties. Let me just confirm it. That's what it is here, 1 through 8. That's right. Which means 1, 2, 3, 4, 5, 6, 7, and 8. Which means the first couple of them are easy. The next 2 or 3 that you will find there are going to be medium. And 6, 7, and 8, particularly 7 and 8, are hard questions. As soon as you finish with the graded questions, so number 8, when we get to number 9, we have 10 of them, 9, 10, 11, 12, 13, 14, 15, and 16, 17, and 18. The scale starts all over again. On a scale of 1 to 10, number 9 is number 1. It's a very easy question. And then 16, 17, and 18 are hard ones. So these are hard ones. You understand? Keep that in mind, because when you get to number 6 and 7 and 8, if they tend to take too long, don't spend too much time on them. Do what you can, do the best that you can, narrow down your odds, and just pick an answer choice and move on to the graded questions. Number 1. It says x minus y is 8. X minus y is 8. We are also told that y equals 3 times z. And in addition to that, we are told that z equals 2. Well, if the value of the z is 2, then y must be 3 times 2, because z equals 2. And y is 3 times 2, which is 6. We put it back in this equation, we find that x minus 6 equals 8, therefore x must be 14, because 14 minus 6 equals 8. Very simple, very straightforward. Of course, it's only number 1. Number 2. It says Todd is older than Martha. Alright, so Todd is older than Martha. So whatever the age of Todd's age, that age is more than Martha's age. We're going to represent T. We're going to represent Todd's age with letter T. T represents the number of years of Todd's age, and that number, whatever that number is bigger than Martha's age. Todd is older than Martha, but younger than Susan. So here is Susan's age, and Susan's age is even higher than Todd's age. Susan is the number of years Susan has is even more than Todd, and that's what we get in equality. And since the answer choices are not written in terms of greater than, they are written in terms of less than, we have to reverse the order. So M, I should line them up properly so you can see them. So M is less than T, which in turn is less than S. And that's our answer. Whichever one that agrees with it is what we're looking for. And it happens to be answer choice A. Number 3. Number 3 on the next page. Page number 713. It says, if the areas of two regions are equal to each other, and the sum of the two regions is 5. So if they are equal to each other, we have two areas, A plus A, we are told, is 5. They are equal to each other, which is why we're using the same letter, which means A must be 2.5, because 2.5 plus 2.5 is 5. What is the question asking? What is the average of the two? Well, the average is 2.5, because they are both equal to each other. Average of 2.5 and 2.5 Average of 2.5 and 2.5 is 2.5. But of course they do not write as 2.5. There are no mixed fraction in this answer choice. So we have to convert this 2.5 into 5 halves. Because 5 halves of course makes 2.5. 5 halves, 2 halves will make 1, another 2 halves will make another 1. So 1 plus 1 and then half, 2 halves of course. Number 4. Number 4. I'm going to erase all of this now. Let S be the set of all integers that can be written as. So we have a set S, which is a set of all integers that can be written as n squared plus 1. If an integer can be written as n squared plus 1, then it will belong to the set. For example, does 13 belong to the set? The answer is no, because 13 can be written only as 3 squared plus 4. We need 3 squared plus 1. 10 would belong to the set. 10 can be written as 3 squared, you see, 3 squared plus 1, therefore 10 will belong to the set. 13 does not. What about 26? 26 can be written as 5 squared plus 1. 26 will belong to this set, but 25 will not. Our job is to go through all the answer choices, there are 5 of them obviously, and find one number that does belong to this set. Let's start then. Answer choice A says 16. Well, 16 can only be written as 4 squared plus 0. That doesn't work. 16 does not belong to the set. Next one is 28. 28 can be written as 5 squared plus 3. We need n squared plus 1. That doesn't work. You see? It has to be plus 1. It cannot be minus also. It cannot be minus either. It has to be plus 1. For example, 28 can also be written as 36 minus 8, which will be 6 squared minus 8. But we're not looking for negative 8. We're looking for positive 1. B does not work. C says 35. Now 35, you have to pay attention here, because 35 can be written as 36 minus 1. It can be written as 6 squared minus 1, but we need n squared. This is n squared minus 1. We need n squared plus 1. 37 belongs to this set. 35 does not. D says 39, which can be written as n squared plus 3. D does not belong to the set. The correct answer here is A. Why? Because A can be written as 50, can be written as 7 squared plus 1. There you go, n squared plus 1. Any integers can be written in this form, n squared plus 1, belongs to the set. This set consists of, in other words, what they're telling you here is, this set consists of all the perfect square plus 1. So you find a perfect square, 1 is a perfect square, plus 1, 2 belongs to the set. 9 is a perfect square, plus 1, 10 will belong to it, so will 5, so will 17 and 37 and so on and so forth. 101, you get the idea. Number 5. That's it, we're done with this thing. Number 5. In number 5, they give us a little picture here. Let me reproduce it here. We are told the picture is not drawn to scale. Alright. So here is our circle. And the triangle sits something like this. We are told that this is y degree and this is x degree. In the picture above, O is the center of the circle, which is what I suspected. O is the center of the circle right here. Is the center of the circle. Now before we proceed, what you have to understand here is that because we've just been told that O is the center, that means this line that we're doing here, let's give it a name here so we can talk about it, let's call it A and B. So what we have to realize that O to A is the radius, and so is O to B, because it originates at the center and goes all the way to the edge of the circle. And because they are both radii, therefore they are both equal to each other. In essence, what we have here is an isosceles triangle, because if these two sides are equal to each other, if OA is equal to OB, then if this is angle Y, then so is this one. So it looks something like this. The triangle that we have is this. This is Y, this is Y, this is X, and this is A and B, and this is our O. These two sides are equal because they are both radii. Let's see what they're asking. If X is 40, alright, so this angle we are told is 40 degree. What's the value of Y? Oh, this is too simple, because we know 40 plus Y plus Y, the sum of the three angles in the triangle, has to equal 180. So if this is 40, then 2Y would have to equal 140, which means Y is 70. This is 70 degrees, and so is this one. Because 70 plus 70 is 140, and then top one is a 40 degree, giving us a total of 180 degrees. Number 6. A simple square, we are told, a simple square is any integer greater than 1 that has only 3 positive factors. Only 3 positive factors. Itself is square root and 1. So if we have a perfect square, 36 is a perfect square. Our job is to find the factors of 36, and as long as 36 consists of only 3 factors, 1, which of course is just a theoretical curiosity because every number has a factor of 1. 1 is a factor of any number because any number can be divided by 1. And then itself, which is also a theoretical curiosity because any number can be divided by itself. In other words, we're looking for a perfect square that can only be divided by its square root, itself, and 1. Which of the following is a simple square? Not perfect square, rather, which of the following is a simple square? They're putting simple square in quotation. Let's find out. Let's start with E. 33. What are the factors of 33? 33 factors of 33 are what are the factors of 33? 1 is a factor of 33, but then again 1 is a factor of any number, and then 11. Well, right there it kills the deal, because 11 is not. Oh, I left out 3, didn't I? Oh, there you go. Right there, number 3. 3 kills the deal because we're looking for a situation where a number has only 3 factors. 1 itself, you see, 1 itself, and then its square root. But 33 is not a perfect square. In other words, 3 is not a square root of 33, and neither is 11. The square root of 33 does not equal 11. It does not equal 3, so that does not qualify. 64. 64 is a tricky one because it has several factors, and therefore you can tell right away that it will not qualify. We're looking for a number that has only 3 factors: 1 itself and its square root. What are the factors of 64? 64 can be divided by 2. It can be divided by 64 can be divided by 1. It can be divided by 2. It can be divided by 2 squared. It can be divided by 2 cubed. it can be divided by 16, it can be divided by 32, and of course itself. So of course any number can be divided by 1 and itself, but in addition to it, it is supposed to have only one other factor, which happens to be a square root. That does not work. How about C? C is 81. What are the factors of 81? Let's find out, shall we? 81, just divide by 3. Let's divide by 3. How many 3's in 88? 8 has 2 3's. The remaining 2 goes and joins 1, becomes 21. How many 3's in 21? 21 has 7 3's. 27, let's do it one more time by 3, and that will be 9. Let's do one more time, that's 3. So what are the factors of 81? Well, 81 is a factor of 1, 3, and then 3 times 3, which will be 9, and then 3 times 3 times 3, which will be 27. Did I leave anything out? And then finally 81. But of course we are just wasting our time, because as you can see, in addition to 1 and 81, it has 3 other factors. The fact that none of those 3 other factors is actually its square root is not even the point here. It's not even the point here. The point here is that it has 3 other factors. It's supposed to have only one other factor. So therefore, as I said a little while ago, the fact that it has 3 other factors other than itself and 81, other than itself and 1, it has 3 other factors, and that is actually the point. That is actually the point, because it's supposed to have one other factor, which is the square root of itself. It doesn't work. In other words, we need not bother to see if any of these is actually a square root of 81, because it doesn't matter. That's the moot point. (100). What are factors of 100? 100 is way too many factors. Let's do on the top, 100. Again, we shouldn't have to waste our time. In the real exam, we shouldn't have to waste our time to see that 100 would not work, because it has way too many factors. 100 can be divided evenly into, can be divided evenly by 1, 2, 4, 5, 10, 20, 25, 50, and 100 itself. So it can be divided by itself and 1, of course, but in addition to it, it can be divided by all the other factors. It's supposed to have only one other factor, which is its square root. The answer, of course, is A. Let's take a look at it. What are the factors of 121? The factors of 121, because 121 is 11 times 11. The factors are 1, 11, and 121. In other words, 121 cannot be divided by any other number other than these 3, and therefore it qualifies. 121 is a simple square. 121 is a simple square. Why? Because it can only be divided by 1 itself and its square root, and no other number will divide even into 121. The answer is A. That was it. I will see you tomorrow, okay? Bye now.